communicating to us so that we will comprehend what you have designed for us today. We pray for the members, oh Lord, who have joined and who are yet to join. We pray in the name of Jesus that all minds be open, oh Lord, to really comprehend, Father, Lord, what you have designed for us today. Have your way, oh Lord. In the mighty name of Jesus Christ, we pray with thanksgiving. Amen.
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 Okay, so guys, we are very sorry. I think our moderator is having issue with his network. So without wasting much time, we will just kick on moving by introducing our speaker for today. And fortunately for us, those who were here yesterday, we had this amazing speaker by the name Mr. Clement Chumase. He's a final year student in Catford University in UK. A PhD. He's pursuing his degree in PhD mathematics. It's very good in when it comes to mathematical modeling of infectious diseases and biological system. Clement is an expert in statistical and mathematical modeling, which include regression model, diseases model, functional data, and so forth. So tonight, guys, great men and women, wonderful people, let's welcome Mr. Clement Chumase as he takes us through today's program.
All right, thank you very much. Okay. All right, so can I proceed now?
Yes.
Okay. Yeah. So I'm actually in Cardiff University. So I had a different name. Yeah. So I'm a final year PhD mathematics student in Cardiff University. But there's something I forgot to tell you yesterday, because Gilbert told me a lot of people were inquiring about certain things about me and all sort of things. So one thing I just wanted to just chip in quickly was in 2018, I actually did my undergraduate studies in University of Ghana, School of Mathematics and Statistics, and then I did my MPhil in statistics still with University of Ghana, and then fortunately for me, my research won the best research in mathematics across all universities in Ghana in 2018. So a Google search of my name would help you know a lot about me. So I forgot to chip that in just to motivate you that anytime you are doing research, your goal is not just doing research to pass a thesis or something. Do and do it well. That's basically what I wanted to send across. All right. So without wasting time, I'll just explain the things we are going to do today, and then I'll share some screens and we'll move on. I aim to spend at most 1 hour 30 minutes. So I will speed up a little bit so that we can learn as much as possible. And don't forget that everything I say will be recorded and also uploaded on YouTube. And then yesterday I made mention about this initiative I started. So basically, I started the initiative to promote mathematical programming among students from Africa, but anyone is welcome to join as well. By mathematical programming, we are making use of R. So R programming language is, like I said, is actually the best statistical programming software you can ever use. And then if you use those standard softwares I mentioned about Stata, SPSS, eViews, even Excel stats and the rest. And one thing you should notice that not every statistical analysis can be done in there, especially when things start getting complicated. So for instance, in SPSS, there's no way you can do maybe generalized linear mixed models, even panel regression and the rest. So that's just to say that because some specific softwares were developed for some specific tasks. So it was later that others decided to add on extra functionalities. So those statistical softwares cannot technically, not all of them can technically do very advanced statistics. Okay, so most of them, when you talk about, let's say, machine learning algorithms, I mean, SPSS, Stata, the eViews, I mean, none of them can attempt or can do any of these. So R is very robust, and you can use it whether you are in any field. Okay, so keep that in mind. So you shouldn't necessarily be a statistician before you can use it. And with the beauty about the programming language is that you are able to write your own functions within the language to be able to do very complicated tasks. Maybe tasks that you would have done one at a time, you can actually combine using some loops and other things and get all your results at once and so on. So we will talk about that shortly. And one thing I wanted to also clarify was, yesterday I realized that others were complaining to Gilbert, who is my very good friend, that the content was a bit technical. Okay, so what I wanted you to keep in mind is I was giving you, or I want to give you the things you really need, especially when things get tougher. Because if you want to do publications and if you want to do very good work and other things, there are instances you have to step up a little bit. So this, everything that I said, are things you really need, and there are things that are dominating that if you're able to sail through successfully, you really appreciate everything we are doing. And because in my free online class, we've already had about 6 lessons. And then, so meaning that for our programming, we've actually gone into the basics from scratch in the first YouTube video through to the 6th video. So I wouldn't want to waste any much time trying to deal with basics at the moment, because I will share, you have access once you send your emails to either me or to, I think I added my email address. Maybe I would add it again, just in case those who want to still join, because the course I'm going to share, I mean, everything you're going to learn, you can technically upload them on something called Piazza. So Piazza is like an online platform that I use to manage the class, where you can actually download all the R script, the script, everything, data, everything we are using, everything will be there. So, and if you are not fully part of the class, you cannot get full access to those softwares, and then you don't pay anything for joining the class. So why don't you just take advantage of that as well? So I wouldn't go much into details, as in much into the basics, but I'll try as much as possible to explain. And since this is recorded, at any point in time, don't feel intimidated that maybe you don't understand something, or maybe I was going fast, because you get a YouTube video and you can actually watch it at your own pace. Okay, so I just wanted to make it clear that usually when we are teaching these kind of complicated stuffs, you don't expect to absorb everything. It's actually after the meeting, then you sit down, watch at your own pace. You can pause, you can watch at a point. When you feel tired, you stop and continue later. So these are some of the things I wanted you to understand. Okay, so I'll be using an IDE. I explained IDE to the integrated development environment, and I said IDEs technically help us to run programming languages. Okay, so if you look at R, if you've heard of RStudio, so don't confuse R with RStudio and RBase. R is the language itself, okay? But to run that language, you need something to run it. And that thing you need to run it, not just R, any programming language, we use something called IDE, which I said integrated development environment. Okay, now for RStudio, it's a typical IDE for running R. So RStudio is purposely for running R. So it doesn't mean that that's the only software I can use to run R. I use something called Jupyter Notebook as well. So I initially started with RStudio. In the first YouTube video, the second YouTube video, I was using RStudio for people to be familiar with R. And over time, I switched to the Jupyter Notebook so that people will now appreciate the importance of Jupyter Notebook. By the time you are done today, you would understand why you need to switch from RStudio technically to Jupyter Notebook, especially if you are doing a PhD study or master study where you might have to be sharing results with supervisors. You would want to use Jupyter Notebook because it's powerful and you can run more than 30 different programming languages at the same time on that IDE. Okay, so just keep this in mind. But for those who know nothing about RStudio, I just want you to have a fair idea how RStudio will look like after installation. So let me just quickly share my screen. Um, Okay, so basically, in order to install RStudio, so if you join my class, which is free, okay, there are a series of announcements on the Piazza website where installation of R is there strictly, so you can easily install. But keep in mind that there are several ways you can install RStudio. So yesterday someone mentioned Anaconda. So first of all, Anaconda is actually it's more like an app that has several distributions where you can download several applications from it. Okay, so RStudio is one of the applications. Technically, to install RStudio on your system, you first of all have to install something called the RBase. So the RBase is also can be used to run R. Okay, the RBase is also can also be used to run R. But the reason why we don't advise people using the RBase, especially for beginners, is that with the RStudio, with the RStudio, you find out that once I start typing, the functions can start popping up. So it makes things easier. And you realize that for the RStudio, once you open for the as a beginner, once you open this, the kind of screen you're going to be seeing. Okay, here is supposed to be empty. So let me empty it. So I think okay, fine. So technically, so when you open it for the first time, this is what you're going to see now, and then here is where your plots, your graphs will appear, and then this is what we call the console. You can actually use R as a calculator, so you can technically multiply numbers. I'm sorry, I was multiplying 3 and 5. Okay, you can technically even plot, let's say a date. Let's say I'm generating a data from normal distribution, for instance. Let's say 100 data points, and let's say I want to look at 8 plots. So don't worry about this. This is not what I'm going to do. I'm just trying to make you familiar with the RStudio a little bit before I switch to Jupyter Notebook, where the codes. Okay, so you realize that if you plot anything, this is where it pops up. Okay, but in the RBase, it will not look like this. For the RBase, when you plot it to open a different window and so on. So Jupyter Notebook is user friendly. And then to save all your results if you watch my first YouTube videos, the second, you'll be able to save all your graphs. And even by the end of this study, I've also used an automated way you can technically save into a repository without wasting too much time or doing anything manual. Okay, fine. So the first thing is there's you can see this small plus sign here. When you click on it, then you select R script. It's always advisable to write your codes as a script. Everything I did here, if I should close R at the moment, I'll lose everything that I did in the console. So this is the console. You can actually take it upwards, downwards. Okay, you can technically expand this. You can decrease this. You can actually increase your font size. So here, so what I did initially, I could have just copied. I should rather be doing them here. Okay, when you write any code here, you just click run and it runs for you. Let's say, let me change the color to blue. Or let me add two random variables. So let me say rnorm. So don't think about these. I just want you to have a particular message. Then I'll switch to something else. Okay, so suppose I'm considering bivariate there's standard normal, and I'm plotting this, and let's see what happens. So technically, there's an assumption that for standard normal graphs, if you plot two standard normal distributions, you get something that looks elliptical. Fine. So fine. So it meant that this is where you'll be writing your codes. To save your script, you have to click just normal where you save anything. So file, save as. Okay, and it's always advisable to create a folder on your desktop or somewhere, okay, where you'll be saving all your R scripts. Okay, so if you find out that for me, when you go to my desktop, okay, for the sake of the class, I made them create a folder called data and data underscore R. Okay, I mean data analysis underscore. You can label it anyhow you want. So here, if I want to save this script, I just type the name, whatever name I want to give to it, maybe trial. Okay, let's say try, and then I click save. So now I have saved this. So it meant that I can keep on doing anything I want to do. So maybe what else do I want to do? So maybe let's say maybe histogram of this, for instance. And then I run. Okay, so to run, keep in mind you can either highlight this one and click run. Suppose you have a very complicated function, or you can just put it at any part of the line. You can even put it here and then run. So here too, I can add a color. And keep in mind that if you specify any number to, it's a color, okay? Because every color in R has a specific unique number. Just that if you want to choose the color you want, it just indicates the color by bringing your quotation, the quotation sign, and the name of the color. So yeah, I just put 6. I don't know what 6 is. Anyway, so there's the kind of color I get. So now at the moment, you can, to save this one, just click Control S and you saved it. Okay. So technically, I can suppose I've lost this. Suppose I open R for the first time, and then I want to call back the script that I wrote earlier. You just have to go to File, then you go to Open. Okay, then you go to the folder that you saved. So if your folder was on desktop, okay, and you save the folder where you'll be saving all your, so keep in mind, it's a good programming practice to always have a folder on your desktop or anywhere you want, such that you'll be saving all your results, okay? And that folder is technically what we call repository. The very moment you start making use of that repository, then you can see it as a working directory, which we will see very soon. So here, if I want to call back that data, that script, I said it was try, I just click on it and it comes back, okay? But if I had typed anything on the console and I had closed the Rstudio, I'll lose everything. All right, so without wasting time, this is not what I wanted to do. So let's switch to the main task for today. All right, so let's go. So first of all, I said setting up a working directory. So keep in mind before you start. So this is Jupyter Notebook. Technically, it opens with one of your browsers. In the CIS video, I've explained extensively how to. That is the CIS YouTube video. I've explained extensively how to install Jupyter Notebook from Anaconda and after installation, how to add R kernel to be able to run R. In order to run any programming languages apart from Python, you need to add its kernel or to Jupyter Notebook, or else it won't run. But the beauty about the Jupyter Notebook, as you can see, you are able to write your codes, and then let me take this. You're able to write your codes, and then when you come down, you'll be able to see all your results. Everything will be visible. So suppose I was making a presentation, I can technically, as I'm doing, I can technically use Rstudio, Jupyter Notebook to make presentation to supervisors. You can use it to make presentation to even like in a company or anything. And you have your codes, you can write equations and so on and so forth. And I've extensively explained that in the C's YouTube video, how to go about all these. And then by the time you finish the first YouTube video to the C's one, you'll be very, very good. So keep that in mind, and take advantage, and don't forget to sign up to the class for free and just learn. Okay, fine. So the first thing we do is to always set a working directory. Okay, how do we set a working directory? So I told you I created a folder on my desktop. So let me share my desktop screen. Let me open. Okay, so let me share my desktop. Okay, fine. So now on my desktop, I have technically created this folder. So it implies that anytime you create your data, so first of all, so that's the folder, that's all my R scripts and the data we've been using for the class. Everything is in there. So if I click on this one, I created a specific folder for today's class called data analysis, NUGS-Shanghai. Fine. So if I open on this one, okay. So now this is the data we are going to use for today. Now I just want you to have a fair idea how you should always enter your data. You should enter your data before you can do any analysis on using any software. So I'll share the screen again for the Excel sheet. So let me share. Okay. Please, can you see the Excel opening? Oh, let me. Okay, yeah, fine. So can you see the Excel sheet now?
Yes, please.
Yes.
Okay, so please, this is one caution. If you don't enter your data well, you cannot do any analysis with it. So that's one thing we have to be very careful. And this is how every single data, no matter the model you are fitting, should look like before you can use any software, be it a programming software or any statistical software. This is how your data should always be entered. The first row should always be the variable names. So for instance, this is a cross-sectional data like we explained yesterday. So it means each row corresponds to each subject, isn't it? So this is technically how I expect you to always enter your data for any statistical analysis. Okay, so that is very simple. Now, in order to import into R, if you have a data in SPSS, you can technically import it directly into R. Okay, but you need a package to do that. If you have a data in Stata, you can technically import into R and do every analysis in it. Okay, so keep that in mind. Even if you have a data in SAS, you can also import. Okay, so keep in mind that with R, you can import data from different softwares, and it's possible. But the basic way you can import a data where you don't need a package. For instance, if you want to import an Excel data directly, you need a package in order to import Excel data. But in Excel, you can save an extension. So if I go to File and I go to Save As, okay, then I go to Browse. Technically, if can you see the browse, please? The what pop-up? Can you see it? Okay, let me. Okay, can you see this one? Hello? Can you see the pop-up screen?
Yes, please.
Yes,
Yes,
please.
please.
Yes, please.
So technically, if you had Excel, if you have a typical Excel, you wouldn't have seen the save as type as CSV. You would have seen it as Excel workbook. Okay, if you open Excel, you create a data in Excel, the extension automatically is the workbook. Where is the workbook? So it could be any of these. So see it as it could be workbook, but not with the 5 points. So it wouldn't be in CSV. So always keep in mind before you import data, if you don't want to waste your time using how do you call it, using a package, always save your Excel. Just go to the save as type, okay, and change it to, keep in mind we have three different CSVs here. We have CSV comma delimited, CSV Macintosh, and CSV MS-DOS. I prefer the CSV comma delimited. So that's the extension you should always choose. Then you click save, okay? So keep in mind, that is always how you should save your your Excel data before you import into R. Even in Python, suppose for those who use Python, and even MATLAB, any language can easily import CSV files. So keep in mind that if you hear CSV file, it's just an Excel that I've changed the save as type or the extension to CSV comma delimited. Okay, so don't forget that. Okay, so now let's just proceed. So back to the working directory. So you realize that now this was the folder where we have the data. Let me just click this side. Can you see this link? You just copy this link and then you paste. Okay, you copy, then you go back to your whether Rstudio. If you are using Rstudio, go back to Rstudio, and then you paste. You write set WD. So this is setting the working directory. I'll explain why it's useful. Then you open your quotation. You paste. Now you realize that when you paste, the slanting bars are pointing towards the left. But with this one, is pointing towards the right, isn't it? So keep in mind that you have to now change this to the right. Just change this to the right. You change everything to the right, all the slanting bars to point towards the right. And then you now run, okay? After running, it meant that you've technically set a working directory. What is the importance of setting a working directory? It means that now, if I want to import the data, I can easily call the data without writing without any complication. And I can also save every resource that I produce directly into that folder. Okay, so the working directory is just the folder the folder of interest. So just pasting and changing the slanting bars to point towards the right, indirectly you've set the work directory such that you can easily call a data into R without effort, and you can save your results directly into it. Okay, fine. So what is the essence of packages in R programming? Keep in mind that you can create your own functions and you don't need a package. In essence, they are inbuilt functions already in R. But what is the essence of packages? So packages are simply functions people have written such that without loading that package, you cannot make use of their function, okay? So you realize that I've created a very complicated function. When you go down there, I mean, we'll get there very soon. And that function, I can technically write it as a package, or I can actually create a package based on that function. If I create a package based on that function and you want to run that function, okay, what you need to do is that you have to first of all install the package and you load it. We use install.packages in brackets, the package name, and then that is what we use to install a package, okay? And I've explained how to install packages and everything if you watch the first YouTube video, the second YouTube video, you'll be fine how to do that in Rstudio, and then how to do that in Jupyter Notebook. For Jupyter Notebook, it's straightforward. For Rstudio too, it's straightforward. Just copy the same command and paste. Everything I'm doing here, you can technically just copy and paste into Rstudio, and you run and you get your results. Just that the only thing is that you will not be able to see the view the way I'm seeing it in my Jupyter Notebook. So that's one of the. And with this thing, if I want to send you the script as a script you would have written in Rstudio, I can just go to File and then go to Download As. If I go to Download As, I can download as R. And then this, if I download as .R, it will just be the same thing as the script you would have written in Rstudio. So this is how interesting Jupyter Notebook is, because there are instances your supervisors might not know Rstudio in the first, Jupyter Notebook, how to use it in the first place. So it means they might be interested in the script itself. So suppose your supervisors are interested in that script, all you need to do is just to download this as that, and then you are good to go. And if you want, you can also download it as an HTML file, which is actually the best option. I think you should download always your script. Why? Because with the HTML file, you are able to see everything the same way you are seeing. I'll do that for you to see at the end of the class. Okay, so you're able to see your results, your code, and everything. So and you can easily save your graphs. So to save your graphs, we'll see how to save your graphs in so many ways. So let's just proceed. So first of all, this is how you install any package. And after installing packages, keep in mind you install a package once. After installing the package, you don't need it anymore. So it means at the moment I've used install.packages with quotation movement to install the package movement. If you want to install the package ggplot2, you have to also just copy this in your RStudio. You just type ggplot2. And keep in mind, you need an internet to install a package. You need an internet to install a package. But after installing your packages, you don't need internet again, and you don't need to install them again. But you always need to load them. And we use the library around the package to load. Keep in mind, when you're installing, you need a quotation. But when you're loading, you don't necessarily need a quotation. So at the moment I'm loading, let me take quotation out from one of these. So if I run this, sometimes when you get that message, it's not an error. You just run it again and it disappears. Fine. So with this one, I didn't put quotation and it still ran fine. So this is how we load a package. I didn't make use of all these packages. I didn't make use of some. I didn't make use of this. Let me take it out. And I think I didn't make use of this. And I also didn't make use of this for this presentation. Okay, fine. So, and with Jupyter Notebook, when you run your graphs, they are at the beginning stages. When you run your graphs, it will only cover half a page. If I want to prevent that problem, okay, all I need to do is to run this particular code, and then it will help me to get a full view. To run, I use Control Enter to run. Fine. Now let's import the data. So to import the data, you just have to write read.csv. That's why I told you that always save this Excel extension as a CSV file. Yes, yesterday, some of you contacted me, some were talking about their research and other things. If you follow just this particular presentation, okay, you should be able to go about your results yourself. You technically don't need anyone. So by the end of this, you should be able to do a lot of things yourself. And if you're able to go through the first YouTube video up to the 6th YouTube video for my class, together with this, you should be fine. You don't need anyone. Okay, so keep that in mind. Fine. So the data name was, I named it as meta rates underscore data. So don't make sure you don't get the labeling wrong. So you just have to get the name of the data, then you just add the CSV. So when you run, you just get your, so this one is importing the data directly into R. And this is the easiest way. There are so many ways to import the data, but this is the easiest after setting a working directory. So the N here is, I just want to see the first 10 rows. If I wanted to see the entire data, I would just copy this. And keep in mind, this is what we call an object. Okay. So if I was importing the data was called meta rate underscore data. But when I import it into R, I should be able to save it in a certain folder, such that in that folder, anytime I call back that folder, then it's like I'm calling back the data, okay? So anytime you assign something to a code, we call that thing an object, and they are very useful. So meaning that at the end of the day, now anytime I want to talk about the data, this is what I'll be using to represent the data, because after importing the data, I've kind of saved it as this one, okay? So let's just proceed. Fine. So, and the next thing is always check whether they are missing values in your data. So these codes you are seeing, don't feel intimidated in any way. That's why I'm saying that you are going to start, it's advisable to start my first YouTube video. You don't even need to watch the YouTube videos if you can even work with this. But if you really want to understand the R software and also understand the programming and a lot of things we've already done, then I will entreat you to watch the YouTube videos, and if possible, subscribe to the class, and you would really learn and appreciate a lot. So we use this is .any around the data to ask whether there's any missing data. If there's a missing data, it will tell us true. If there's no missing data in your data, it will tell us false. Okay. So before then, I was supposed to tell us what we are going to work through with the data. So the data we are working with, first of all, is so the goal for the whole presentation is that we want to determine or to find out the determinant of meta rates in the United States based on an existing empirical data. So this data I'm using is a data in R. So there are a lot of R data. So if you click on this link, which when you get the HTML file, when you click on this link, it will give you access to all R data. Okay, let me just click on that since you can see. So here, these are all data that are free in R. You can just click the CSV to download any of the data, okay? So suppose you want the data on stocks, you want the data on anything, employment, you just want the data on something to work with or to practice with them, you just click on that and you should be fine. Now, so the data we are working with is murder rate, and we want to determine the determinant of murder rates in the United States. Okay, so this is the description. The data has 44 observations with 8 variables, okay? And these are the variable names and the variables we are working with. So the rate, which is what we want to predict, okay, is actually measured per 100,000 of the population. And we have a variable called convictions. And that conviction is actually the number of convictions divided by whatever, divided by the number of murders. And we have execution, which is the average of execution, whatever. And then we have time, we have income, and we have labor force participation, and we have proportion of population that are non-Caucasians. And then we have southern, and then the southern is just technically like residential status, whether you are within the south or not. So it's just a yes or no. So at the moment, this is the only variable that is yes or no or categorical in our case. All the rest are numerical. Okay, so these are the specific tasks we aim to achieve by the end of the presentation. So first of all, the first task is we want to add a new variable. So there are instances where you have a data, let's say a data on height, and you have a data on weight, and you want to compute BMI. Okay, and we know that BMI is technically like is it the weight divided by the height square or something? So technically that's the BMI. So the weight divided by the square of the height. So in that case, if you want to get that extra variable, all you can do is that you can easily do that in R. You don't have to go and create it in Excel and waste your time trying to add. No. You can easily do that. So here what we are going to do, and keep in mind that after getting the BMI, and suppose you want to categorize your numerical variable, you should understand that assigning codes to categorical variables do not make them numerical. I think I told you yesterday. However, I mean, you assign the codes to them, the dummy codes, just to be able to work with them, right? But for numerical variables, you can actually convert a numerical variable to something categorical. How? So BMI, for instance, suppose you get the actual BMI after computing the weight divided by the square of the height. And then you want to find, let's say, BMI status, where if the BMI is when it's less than 18.5, then we say that individual is underweight. If it's between 18.5 to, let's say, 20, 25 or whatever, normal weight, above that, obese, and so on and so forth. So that is how we can actually categorize a numerical variable into categories, okay? So what we are going to do is that the variable income, we are going to obtain something called income level, where we will say that the income level is low level if the income is less than 15,000. And don't forget that the incomes are actually in $1,000 US, okay? So and it's medium if it is actually from 1.5 to 2, meaning 2,000, and the high when it's greater than 2,000 US. And then based on that, we are going to compute a summary, a descriptive summary statistics of all the 8 variables or all the variables with appropriate graphs, okay? And then the next is we are going to perform a correlation analysis based on all the numerical variables. Okay, so I told you yesterday, if I forgot, then let me chip it in, that you can only find correlation among or between numerical variables. If you want to find correlation between categorical variables, that is where chi-square test will come in. Okay, so keep in mind that you don't use chi-square test to find correlation or association between two quantitative or numerical variables. No, that is where the Pearson correlation, which is the parametric correlation test, and if non-parametric, we have the Kendall-Tau, the Spearman's correlation. They will come in if you are dealing with the numerical ones. Okay, so keep in mind that chi-square is just like you want to find correlation, but it should be strictly between two categorical variables. But if you want to find correlation between a numerical variable and a categorical, that is where regression can help. So for regression, you can find a relationship between whether numeric against variables which are numeric and some categorical, it doesn't matter, and vice versa. So that's where regression actually becomes very useful. Fine. Then, so we are going to do the correlation analysis with some informative correlation matrix plots, okay? And we'll find out very soon. And then the next thing is that we are going to, like find correlation between income level, because then residential status. Remember, residential status is technical, like the southern, which I said is whether they are within the south or not, okay? So it's yes or no variable. And then the income level, I've already explained that is going to be categorical, and the levels or the categories are going to be low level, medium level, and then high level. And then afterwards, we are going to fit a regression to determine or to find out the determinant of murder rates. Okay, what actually influences the rate of murder within the county. Okay, and keep in mind with the regression, we are going to, since we are making use of income as a predictor, we are not going to make use of the income level. Okay, so here we are making use of income. You wouldn't want to put income and income level in the same model. Sometimes it could be useful, but it's because they are technically the same thing, isn't it? Just that one has been transformed into something else. So you wouldn't want to do that anyway. So let's continue. So now I've imported the data. So we've imported the data and we've checked whether there's any missingness in the data. And here, this is the function we use to categorize the variables into. Let me reduce yeah, okay. So this is the function we use to determine to categorize a numerical variable. So you first of all need to set the threshold. If you remember, I said for low level, it should be from less than 1.5 or 15,000. So it's technically, so here always you need to start with the minimum value, okay? So the minimum is, so start from 0. So because if I say less than 15,000, it meant from 0 to 15,000, but the 15 is not part, isn't it? It's not inclusive. So here you have to set always the low 0, and then this 3 is technically the maximum. How? So if I open a new cell and then I look at the minimum. So if I want to look at the minimum of this, okay, so this is the minimum data, and the maximum, I just put max around this, and this is the max of the data. Okay, if I want to find the mean, I will just put mean around this, and then it finds the mean. Okay, fine. So here we know the minimum, we know the maximum. So here what I was saying was that when you're setting the thresholds, always make sure the first value is set at 0, so that if I want less than 1.5, is the same thing as saying that between 0 to 1.5. Okay, and then the medium was technically from 1.5 to I think from 1.5, but not including 2. I think that's what I said here. I said for the medium level income is from 1.5, but less than 2,000. Okay, so keep in mind. So here I still consider 1.5 to 2, and then the other one, just to say greater than 2. For greater than 2, all I needed to do was to put a maximum threshold, the same way I put a minimum threshold, which is 0. So you realize that the maximum value is 2.39. So technically in 2000s anyway. So this is the maximum value. So I just have to put anything maximum. So I just put 3. Okay. So that at the end of the day, anything between 2 to 3 is the same thing as saying greater than 2 technically. Okay. So that is how. So you always have to set a threshold, and then that threshold will be put here in the bricks. And then this is the variable you want. This is the numerical variable you want to categorize. Okay. And this is how you are categorizing it. And then after categorizing into the 3 groups, this is technically the names we want to give it: low, medium, and high. Okay, so now running this one technically have done the job. Now let's look at the first 6 rows. So when n is maybe 10, it views the first 10 rows. You can, and then I'm using the head. If I use tail, okay, it will actually print out the last 10 rows. So head is for checking, tail is for checking the last, whilst head is for checking. You wouldn't want to print everything. If I wanted to print everything, all I needed to do was just to, let me, and we use the hashtag to comment, okay? So comment means that I'm not treating it as a code, it shouldn't run. So if I should run that data, the data object, it will print out everything. But technically, you wouldn't want to print out everything just to be sure you have your data in there. So we use the head to make life easier for us. Okay, fine. So you can clearly see that income levels have been added. So the new variable I wanted to call income level, all I needed to do was the data name with a dollar sign. Then I write any new name I want to give to, and then it will, and then equals. And keep in mind that we use the less than with the minus, or just equal to. If you don't want to complicate yourself, equal to is okay to assign. So equal to and then the less than are doing the same thing. Okay, so keep that in mind, that the less than with this minus is for assigning, and this is actually also for assigning. But if you want to really mean equality in R, is double equal to, that is equality. You don't have to think about all these complications, because you're going to watch. If you watch the YouTube videos of my class, you should be fine with all these things. Okay, so now we are just trying to increase or arouse our interest. Then you can go back and watch all the YouTube videos at your own pace. Okay, fine. So now we've assigned the how do you call it? We've assigned the variables now. All right. As in we've assigned or converted the numerical variable income to categorical called income levels. And the income levels are having categories low, medium, high. Fine. So this is how simple you can always, so in any data you have, you can always create extra variables in your data. To create extra variables, just bring the data name, bring a dollar sign, whatever variable name you want to give to, and then whatever you are computing. So if it was the BMI I wanted to compute, I'll just extract the weight. So anytime you type the data name, you bring the dollar sign, you're able to extract, then you bring the variable name. Suppose you imported the data, you wanted to know the names of your variables, okay? What are the variable headings? You just type names around the data you run, and this will give you all the names of your variables, okay? Or the names or your variables, okay? So that is always, so it meant if I want to extract, let's say, rate, the data on rate, I just copy this one, and then I bring the dollar sign, then I type rate, okay? And then you have all the rates. There's something you can do. You can also attach a data. When you attach the data, then we don't need, because at the moment, see something. If I run rate, I get an error because it says it doesn't recognize it, right? But the very moment I type attach, okay, I attach this data using this function, okay? So at the moment, if I attach the data, now if I should run rate, it will work, okay? So meaning that this is one of the ways, if you want to avoid using dollar signs, you just attach and it works. But there's a disadvantage attaching data set, which I will never advise you to do, but you can still work and it will be fine for this case. Imagine in R, you can technically import more than one data at a time. So in R, you can technically be working with about 10 different data sets with different scripts, whatever. I mean, even the same script, you can import several data as you want, okay? So keep that in mind. But if you're using something like SPSS, you know that when you're working with SPSS, you can only work with one data at a time, okay? When you're working with Stata, you can only work with one data at a time. If you want to work with a new data set, unless you clear the previous one before you can bring in a new one. So this is actually some of the disadvantages with the other softwares. And apart from that, they cannot do very complicated statistical analysis, or they might not be able to do certain things you are interested in, okay? And I've explained that in my previous YouTube videos. Fine. So here, the reason why I said that attach is not useful and it's not very safe to do is that suppose you imported 2 different data sets or 3 data sets, and they all had a variable called rate. And if you attach one of the data set and you call it rate, okay, or suppose you attach all of them, and they all have a variable called rate, and you're now fitting a model, or you're finding mean, or you're doing something, the software will find it very difficult to be able to distinguish which of the rate are you talking about. Okay, so that's why it's not advisable, especially if you're going to import more than one data set, okay, that has some unique or similar variables, or some variables are unique or the same. You wouldn't want to attach in that sense, okay? Fine, so after attaching, if you realize that it's not advisable to attach. You can detach by typing detach, and then now if I should run rate, it doesn't appear anymore. Fine. But if I want to call the rate, I just have to copy the data name, the object for the data, okay, and then with a dollar sign, you can use this to extract any variable of interest. Okay, so that is it. Okay, now let's go on. Fine. So now we've added the income level to it. And then if you want to check the levels of your variable, the income levels, I just bring the data name because now I'm not attaching. If I had attached, I would just type income levels, levels of income levels, and I'll get what I want. But because I'm not interested in attaching, and I've explained the effect of that, I mean, the negative effect of that, should you have more than 2 data sets of similar variables. Fine. So with this, you type levels around the income of income. That will give you the levels of the income. So it means it has 3 categories: low, medium, high. Fine. You can also use table for checking for checking the frequency for each of the variables. Okay, so technically if I type table of this, it is just going to extract how many observations, okay, or individuals had low income, how many had medium, and how many had this. And you can also use the same table function for cross tabulation. So suppose there's another variable on the southern, right? So I can bring comma, that's, and then southern, fine. So if I should run this one, it will give me a cross tabulation of, and keep in mind, I said that southern is like residential status anyway, but it's just saying whether you are within the south or not. So here it tells us that 10 of the individuals who are within the south actually had low income. Okay, so basically you can use this table function for that. Within this table function, suppose I want to convert this to proportion. Okay, this is what I would have done. Keep in mind that your data, you can use dimension, DIM, around your data to know the dimension of your data. So if I should run this one, it meant the data we are working with is a data with 44 rows, but 9 variables or 9 columns. Okay, always the number of columns conforms with how many variables you are working with. Okay, fine. So that's the dimension. And keep in mind, typing this, treat this as a vector. So I can just let me just copy this one. I can just use the square bracket. We use the square bracket for extracting. So I can put 1 here, meaning that I want to extract the first value of this dimension, which is a vector, because it's a 2, it's something returning 2 numbers, right, as an array. And so if I put 2 here, 1 here, see what happens. It extracts the first one. If I put 2 here, it extracts how many columns. Okay, so keep in mind that if you want to convert your cross tabulation to proportions, I just have to, and keep in mind that how many rows correspond to your sample size. Okay, so I just have to divide this one by the sample size. Okay, so let me just copy this one, come down and paste. So if I should run this one, so these were the actual cross tabulations, isn't it? And then now this has converted them to proportions by dividing each of them by the sample size. Okay, and I told you that the number of rows, since it's a cross tab, I told you for cross-sectional data, every row corresponds to a particular subject or individuals. So it means if you have 44 rows, it meant we have 44 participants. Okay, so that is basically the rationale for that. So this is what we do. But suppose you want to convert this one to percentages, what do you do? So all you need to do is that, once you have a proportion, you just have to multiply this one by 100. If you multiply this one by 100, now we've converted this to percentages. Okay, suppose I want to record to 2 decimal place. Keep in mind, in R, we use a function called round. So suppose for this round, if I type round, let's say 2.45, if I want to 45, let's say 8. If I want to record this one to 1 decimal place, I just put 1 here. And then at the end of the day, you will see only 2.5 because I want to record in just 1 decimal place. If it's 2 decimal places, the number itself is 2.458. If I should run this one, now I have 2.46. I've recorded exactly to 2 decimal places. With this run function, what we can do is this. We can actually paste the cross tabulation that we saw with the comma, and I put 2 here. Here, keep in mind, all this is just the cross tabulation in percentage. And I'm saying that it should run everything in there to 2 decimal place. Okay, so now let me run this and let's see what happens. So if you come here, you can clearly see that it has now converted this into 2 decimal places. So this how handy our programming can be. Fine. So now let's proceed. So this function, so now the first task, after now we've done the first task to create the income level, right, as an additional variable. And we said we should now create our own function to compute summary statistics, and that summary statistics should be detailed enough. Now with my class, I created a very novel function that has never been created before. Now what my function does is that it can pick any data you are using. Okay, so especially someone called me yesterday about this class, asking how can he do maybe summary statistics or something. With this function, all you need to specify is the name of your data, okay, and which column are you interested. You don't even need to know whether the column is categorical. I mean, that variable is categorical or that variable is numerical. It will do everything. It will first of all decide. So this is what the function is doing. It has never been created before. And if you watch the YouTube video, the first one, we started the process. So the first stage, it wasn't very complicated. In the second video, we added more complication. And in the third video, even added much more complication. For now, I've reduced the complication. It's still the complicated function, but I've even made it better just for the sake of this presentation. Fine. So for this summary statistics, these are the things it does. So first of all, it determines for any variable, it determines whether you are numerical or categorical. And if you are numerical, it computes the mean, the median, the mode, the standard deviation, standard error, skewness, kurtosis, and quantiles, 95% quantiles. You don't have to understand all these contents. You just watch the YouTube video, you should be fine. And it should record each of them in 2 decimal places, okay? And then it should plot for each of those variables, it should give me some histogram plots, okay? And then it should choose unique colors. I want to see different colors for each of the numerical variables. So this is one of the things the function is doing. And secondly, if it is categorical, and keep in mind that it should also return all these results as a data frame so that viewing it. Previously, in the previous YouTube video, I was returning it as a list. For the list, it becomes very long and then not very friendly if you look at it. But as a data frame, it's really summarizes everything like a table. Fine. So, and then if it is categorical, it should first of all compute percentages for each of the variables. And after computing the percentages, it should save it as a data frame with the names of the categories so that for, let's say, we will see low level. This is the percentage of individuals who have low level in 2 decimal place, medium in 2 decimal place, high income level in 2 decimal place. And then it should plot pie chart for me. And keep in mind that with the function, I've also made it such that if, let's say, your variables now has, let's say, a particular variable has, a particular categorical variable has about 20 different categories, what my function will do is that it will consider all the 20 categories, do a pie chart for that, and choose different colors for each of them. Previously, in the previous YouTube videos for the class, I use a certain package, okay? And that same package, when I go up here, we call it R color brewer. Okay, so I used this particular package, and what happened was there was a particular color I chose, and it could only do up to, I think, 13 different colors. Suppose your categorical variable had 14. The color that I chose could only do up to 13. So you had to manually add an extra color or something. But now what I've done is that I've chosen a certain function we call rainbow. We call it rainbow. So let me just come down. So here, if I type rainbow, so these are all the rainbow colors technically. So if I put even n to be 50, it will choose 50 different colors for me. Okay, so now I've been able to make it in such a way that it doesn't matter how many categories that your categorical variable has. It will do the pie chart for them and choose unique colors for them. So previously there was a restriction. It couldn't have done more than 13 categories. Okay, you needed to add extra, but now I've made it even more automated. Now keep in mind that in R, let me just copy, let's say income. Let me say this. If I come down here in R, let me create something. Okay, let me just type it here. If I type mean, okay, of income, I get a mean. If I type, which I've already showed you earlier, if I type, let's say median, I get the median value. But if I type mode, see what happens. If I type mode, okay. Oh, sorry. Let me take this out. If I type mode, I just get the type of variable, okay? So technically, there's a way of determining whether a variable is categorical or numerical. So the very moment I use class, okay? Oh, sorry, class. Let me just copy this one. Okay, so if I use class, for instance, and I type this one will tell me whether my variable was categorical, numerical, or categorical. If I add the income level, now it told me factor. So this is a way of deciding which variable is categorical and which variable is not, okay? We use the class, and it looks like the mode is also doing something similar. So the mode is not giving me the actual definition of mode, isn't it? So now how do we find the mode? So for instance, if I wanted to find the mode for, let's say, income level, there's a simple way to find mode. If you remember your statistics very well, we said that the mode is which number appears most frequently. So income level, if I wanted to find a mode, right now, if I use table around any variable, it tells me the unique values and how many categories are in there, isn't it? So if you remember, if I should use the same table for, let's say, Southern, for the variable Southern, which was representing Southern. If I use table around this, it tells me for Southern, it has two categories, and 29 of them are not in the South, and 15 of them are in the South. Fine. So you can also use the table around a numerical variable, isn't it? And if you use it, it will extract the unique values, and then how many people had that unique value. Okay. So here, if I want to find the mode, you can clearly see that the mode will be either 2.04 or 2.07. Why? Because they appeared 3 times, which is more than so they appeared most frequently. So technically, if I wanted to tell the mode, I didn't even need a complicated function. All I just need to use is to type table of this and come and decide. But that is not automated enough. So this function I've created here, okay, if I should bring the get mode, how to create functions and everything, we've already covered them in the YouTube in my class. So this is just to arouse your interest, and then you can now sit down, watch the YouTube videos at your own pace, and you should be fine. And everything I'm doing here, you get access to the script. Everything will be uploaded on the Piazza. You can download the script, practice, and then you can always watch this video once again, and you'll be fine. All right. So we already know what the mode should be. The mode is either going to, and keep in mind that you can have more than one mode at a time, because look at this, 2.04, 2.07 are appearing equal, as in 3 times, okay, equally. So it means this case, I have a bimodal data for income. If there are 3 times, if we have another variable which is also occurring 3 times, then we'll have a trimodal. And keep in mind, there are instances where the mode will not be present, or there wouldn't be any mode. Suppose all the unique values were appearing only one time, then it meant the mode can be any of them. So in that case, finding mode is not useful. Okay. So now I created this function get mode. So if I should run this, see what happens. So when I run this one, it chose 2.07 as the mode. So technically the mode was 2.04 and then 2.07, because this one, we made it so that it should choose. So I think I can also make this function so that it should tell me all the various possible modes, right? So now it's just choosing the highest of the value that appeared most frequently. So that's what it did. Fine. So let me just continue. Okay, so this is my complicated summary statistics function. You don't have to understand anything in here. I've explained everything in my previous YouTube videos. But basically, and I'm just making basic definition of functions, okay? So here, I created a function, and the function should pick the argument data and then the index, okay? The index means the position. So if I want to, so this is what I said, you specify the name of the data. And if you want to know the summary statistics for, let's say, the first column, it means the variable index is equal to 1. If you want to know for the 10th column or the 10th variable, it means the variable index is equal to 10. I've made it such that, first of all, it's extract the variable names. And this one, this function is just extracting the variables. And then here it's now asking, is dot numeric. Keep in mind that if a variable is numeric and you type is dot numeric, it will return as true. If the variable is not numeric and you type is dot numeric and the variable was categorical, it will say false. Or if you type is dot factor of a numeric variable, you get false, okay? Because is dot factor means that is the variable a factor? A factor means categorical, okay? So here I'm first of all asking whether the variable is numeric. And if it's numeric, it should compute the mean, the median, the mode, the standard deviation, standard error. The skewness and kurtosis cannot be obtained directly from the inbuilt R function. So I needed to use a package called movement. So if you check the packages up, the previous packages I showed you, there was a package called movement. It is through the movement I'm able to compute the skewness and kurtosis. So that's why I'm saying that when you talk about packages, it's still like this function I've created. I can actually just create a package, okay, such that it will be Clement's package called summary statistics, that it can be used to do summary statistics in an automated way. You don't have to think about computing the mean, the median yourself. It will just do everything. We are going to see shortly. So first of all, and the quantiles, I've explained everything in the YouTube videos. So here, what I'm doing is that it should now return, the mean, the median, and everything. I'm creating a data frame to store all those results. Initially, in the previous YouTube videos, I use a list instead of data frame. I use a list, okay? But here I'm creating a data frame to make it the view to be much more better, okay? And then the histogram in the previous YouTube video, I didn't bring $ histogram to extract just the histogram. So in view of that, it was printing out extra information about the histogram plot that you didn't need. So here, bringing the dollar and extracting just the histogram plot brings just the histogram plot without having to worry about the bins and other things that were in there. These things, you don't have to worry about any of these. All you need to use is just run this. So it's my own function I'm giving out to the world for free. I will technically run create a package of it, and then let's see what it does. So now let's run this package. Okay, so now I've run my function, sorry. Now, this is what the function is doing. So it means that if you import any data, not necessarily my data, any data, all you need to do is that write summary underscore statistics, then data equals, put the name, the object name of your data, put it here. And if you want to find the summary statistics for the first, let's say variable, you put 1 here. Now keep in mind that if it is numeric, I said, if the variable is numerical, I said it should compute all these, the kurtosis, the mean, and everything. Else, if is dot factor means if the variable is a factor, here too I could have just used the same is dot numeric equals true, and I would just bring it here that if is dot numeric equals false implies the variable is a factor. So I could have just used is dot numeric equals false, then it should do the rest, okay? Or I could equally have just used what I used. Is dot factor means is the variable a factor? If true, then it should compute the percentages, which is being done here, and then run it to 1 decimal place. And at the end of the day, it should paste the percentage sign as well. And then it should create a data frame of each of the categories with their percentages. And it should plot so here I'm going to plot the pie chart. So all what you are seeing here is just plotting the pie chart. Okay, you don't have to worry about the details. Okay, so fine. So here, this is where I wanted you to know that the categories could have either 2 or more than 2 levels. So here, if it has 2 levels, the rainbow color, I'm saying that n is equal to 2. So initially, you can actually use this if you are interested in setting it to specifically red and blue or any color you want. But here I wanted to use the rainbow to make it more automated. So if the levels is equal to 2, then the rainbow should choose only 2 colors. However, if the levels, okay, of that categorical variable is 3 or more, then it should choose the number of colors should be based on the size of the data. So it meant that if the size of the category, so it meant that if the categorical variables are, let's say 10, then n will be set to 10 automatically using the length. Keep in mind in R, length of around a vector gives you how many entries are within that, inside that vector. Okay, so now I've run this. Now see what it's doing. So you realize that now, if you import your own data set, just change the data name. You can, after this class, you can actually practice, okay? Change the data name and then put the index equals 1 means that you are interested in looking at the summary statistic for the first variable or the first column. You don't have to worry about whether it's numerical or not because it will do that for you. So if I should run this one, this is what you see. So here, it tells me that the variable was rate. So meaning that if it was any data you imported, and I'm interested in the first column, it will extract the name of your data, the first variable. And then if it was numeric, it's computing the mean, the median, the mode, the skewness, and this one is the lower value of, or the lower limit of the 95th quantile, okay? And this one is the upper limit of the 95% quantile, okay? Fine. And then I chose, because here, within the histogram, I chose the color to be, if you check the histogram, I chose the color to be equal to the index number. I told you that using, let's say color equals 2, would choose a certain color, okay? Every color in R has a unique number. So here, when the variable is the first variable, it's choosing the black. Black is not very informative, but here I just wanted to show you that I was choosing different colors for different things, okay? Fine. So here, so the next one is the second variable is so if I put 2 here, the same thing, the data name, I just have to put 2 here and I run, okay? If I run, it tells me the variable name is convection and it gives me the mean and everything. And so the very moment you see numerical summaries, it meant the variable was numerical. And then it gives me the histogram plot as well with a different color. Now, when I set the variable index to be 3, it tells me the variable is execution. And if I come down, it also choose a different color, and this is the histogram plot. Here it meant there was nothing, there was no execution value within here. That's why you are seeing missing empty value there. Fine. And then if I set the index value to be 4, so this function is such that any data of your choice, just specify the name of the data after importing into R, and then choose the index number, and it will do that for you. You don't have to think about how the function was written, because the function, if you really want to know the details, like I said, you just have to watch my previous YouTube videos. Fine. So if I come down here, so this variable is on time, and then it extracts the histogram with a different color. And then for the 5th one was on income, it was numerical, it also compute the mean, everything, choose a different color for you. And then the next one is labor force participation, and it also follows suit, as you can see. Now, okay, this one was numerical, it's also choose a different color. So the A variable was actually the southern, which was residential status. So you realize that this time around, I didn't even know whether the A variable was categorical. I didn't know, okay? I just have to put 8. I'm interested in the 8th variable. And it tells me the variable is called southern, and it computes the percentages and the levels for me. So it means it has made your life easier. So with this one, you don't have to worry about discrete summary statistics. It does everything for you automatically. And that's how beautiful, and you realize that it's because of my programming skill that I could create this function. And this function has never been created before, but you can always use it for your own research, and I'm fine with it. Just that don't go and write a package around it and claim it's your own because it's mine. Fine. So here what happens is if you come down, it also does a pie chart for you, and then it gives the percentages, the categories, as you can see. And the income level, if you remember, we created a variable on income level. Income level was the 9 variable. Okay, it's fine. So let me just copy this one. We created the 9 variable. So if I should put 9 here, okay, and I run this, it's income level. So it gives me the percentages, and it chooses a very nice colors for each category with their percentages as well. So this is how automated this function is doing. Fine. Now let's suppose that you wanted to save your plot. Okay, let's say this income level, the income level pie chart. You wanted to save it directly into your repository. You remember I told you we set a working directory. If you wanted to save it directly into it, all you need to do is that you run this same function. So here, the PNG here is, I want to save it with .png. If you wanted to save it as a PDF, put PDF here and come and change this one to PDF. And it will save the same, if you run this, it will save the same thing as a PDF. Like you see a PDF with the picture in there, pasted in there. You can save it as a JPEG format by just changing the extension to PEG, and you run this, it also does that. But I think PNG is the basic picture format that everyone is familiar with. Okay, so here you give the name. I want to, after going to the repository, I want to save it as income underscore level underscore pie chart. You can give any name, but don't, make sure at least, I usually want to, it's good practice you don't space things, okay? It's good practice you don't leave blank spaces. So you can even use a dot, okay? You can even use a dot instead, okay? Or you can use this underscore and you're fine, okay? And then here, because I was interested in, so keep in mind, these functions I've created, okay? Now, if I'm interested in just extracting the output, I just have to copy the dollar with the output, and it will just bring me just the output without anything. Okay, so I think the picture would automatically come anyway. So if I was interested, so if it's rather the plot, if it's rather the pie chart, let me put pie chart here. This will extract just the pie chart alone for me, okay? So basically this plot is what I want to save. So here I just extracted the pie chart, and then running this, the div.off, what it does is that there are instances maybe you made settings to, you wanted this one to have a specific resolution. So you added other extra things, but maybe for different plots, you don't want them to have the same default. In that case, once you type div.off, it meant that after running to satisfy the conditions of this plot, and then it will go back to default setting. Okay, fine. So it's always useful for that. So you can actually use this in your Rstudio. I showed you how to manually save your pictures in Rstudio in the previous YouTube videos. But this one is the automated way of saving it as a PDF, as any format you want, by just specifying the name. And this is the plot you want to plot. And then this, and you run and you're good to go. Fine. Now, the next thing we were supposed to do was to do correlation analysis, okay? So we wanted to find correlation between the numerical variables or quantitative variables. Now, this is the package I'm using. I don't need a package to find correlation anyway. However, this package has extra things that I've never seen in any software. It's called Performance Analytic package. But before then, I created my own function. I like to create functions to do what I want. Okay, so suppose you had a data set, any data set, and you wanted to determine which ones are the numerical ones so that you can now do correlation on them. So now I've created a function called quantitative variables, where this function, what it does is, I wouldn't go into the details, but what this function does is, once you specify any data, okay, any data name, any data, so meaning that I've done it in such a way that it should be able to work on your data set, okay? So if we should run this one, sorry, let me run this. So if you should run this one, it extracts all the variables that are numerical. If you wanted to extract all variables that are categorical, this is what you do. So let me copy this one and then come down, and then let me change this one to, let's say, qualitative, any name you want, qualitative, okay, qualitative, okay, or categorical. Let me just use categorical to make life easier. Okay, so for categorical, all I just have to change here is false, because here I was asking that is the variable numerical. If it's true, then it should return the names. I'll just put false and see what happens. I just put false. Okay, so I run this one. Now I'll copy the function. Okay, come down. Now the function has this argument. The data is the argument. So I always open a bracket, put the data equals, the name of my data was meta_rate. Put that in here, run this one. It extracts just the categorical variables for me. So it means it doesn't matter the dimension of your data. You with this function I just created, you should be able to extract all categorical variables, all numerical variables. Suppose you don't even know what is a categorical variable, it will automatically do that for you. Okay, fine. So let's come down. So the next function was just to show you how you find normality of a variable. Sometimes I told you to use parametric methods. You need to check, especially if you want to use ANOVA to compare means of some numerical variable across more than 2 categories. I said in that case, you might have to check normalities and other things. How would you check normalities? Okay, there are so many ways of checking normalities in R, but the powerful parametric method is called Shapiro-Wilk test. Shapiro-Wilk test, normality test. Okay, so keep in mind that we have Kolmogorov-Smirnov test, okay, for normality. We have Anderson-Darling test for normality. If your data is time series, we have a particular test called Jack-Berer. It's technically also for normality test, but for a time series data anyway. So keep in mind that there's range, there are series. You even have the skewness ketosis normality test there. But the Shapiro-Wilk is a parametric test, which is technical, and we have the Shapiro-Francia. So the Shapiro-Francia is also a normality test, but among all of them, the Shapiro has the highest power. But keep in mind that it can only do up to a data having up to 5,000 data points. If the data is extremely large, more than 5,000, it will not work. In that case, the non-parametric test will come in. So that is where you use the Komogos-Smirnov, but the Anderson-Darling test actually has a better power in terms of the ability to, to perform. It has a better power than the Komogos-Smirnov test. So you would want to use Anderson-Darling test instead if you have a very large data set. Or Komogos-Smirnov is fine. You can also stick to that. So now suppose I want to check normality for just the rate, the variable called rate. If I should just type Shapiro, if I should just type Shapiro.test, okay, and I run this one. So this is the p-value. And keep in mind that for normality test, your null hypothesis is that the data is not normally distributed. The null hypothesis is that the data is normally distributed, and the alternative is that the data is not normally distributed. This is fixed. You have to know it by heart that if you are doing normality test, you expect the p-value to be greater than, let's say, 0.05, which is your significance level, before you can conclude that your data is normal, okay? And if the p-value is less than 0.05, meaning that if there's something very small, then it implies that your data is not normal. So meaning that what you would have defined as if the p-value is significant, then it means the data is not normal. So just keep in mind that for significant p-values for normality test implies the data is not normal, and insignificant normal p-values technically, meaning that when the p-value is greater than the alpha level, that actually indicates that the data is how do you call it? The data is normal, okay? So keep that in mind. So this is basically how to test normality. But I wanted to test normality for all the numerical variables. Do I have to just copy this one and paste? And let's say I want to extract for, let's say, convection. Then I also come and then I paste it here and I run. And then it tells me, and keep in mind, whenever you see something like E exponent negative something, it means that this is technically the same thing as saying 0.00004 4 zeros comes, then 874. And if you were doing any statistical analysis, you would want to just report this one as p less than 0.001, and you should be fine. So you don't have to. So keep in mind that if you see the minus whatever, so if it's -7, it means six zeros comes before the actual value. Okay, so keep in mind. And anytime you have such minus, you just would want to report your p-value as this. And usually in your research, report p-value in 3 decimal places, and I think it's fine. So to find normality of, suppose all your numerical, now we have 1, 2, 3, 4, 5, 6, 7 numerical variables. Do I have to do this manually for all of them? But this is the basic function. So all I needed to do was to create my own function around this function such that it will do normality test for all the numerical variables, okay? So it means that with this function I've created, I just created it for you so that if you want to do normality test, okay, first of all, you don't even have to worry about which of the variables are numerical and which are not numerical. All you need to do is that just copy the normality underscore test, put the name of your data, okay? Okay, so now let me just run this function. If you put the name of this, it will tell you that the numerical variables were these. So rate, convection, these were the numerical variables. So you don't even need to know whether your variables are numerical or not. It will extract them for you. And then it will do the normality test for, so it means if you see this double index 1, the 1 means for rate, because rate has an index of 1. The index of 2, then if you want to know which variable has, this is the normality results for when the index is 2. Which one is 2, then it's convection. So if I come here, 7, which variable is 7, then it is 7 is non-CAUC, whatever. Fine. So now, how do you determine which ones were normally distributed? So you realize that this p-value is like 0.000, like 4 zeros, and then so very significant. So I told you that significant p-values for normality test technically implies the data is not normal. So it meant that the first variable was not normally distributed. This one was not normally distributed. This one too was not normally distributed. But this variable was normally distributed because the p-value is technically greater than 0.05. Okay. And then this variable too is normally distributed. This one too is normally distributed because the p-values are greater than 0.05. This one is not because the p-value is significant. So this is just to explain. So I've created this function for it to compute normality, do normality tests for any data, and then it will extract just the numerical variables for you. Okay, fine. So you can use that. So if you remember, I said I wanted to also obtain correlation matrix plot. So you use this function. So this function, so in R, okay, let me create a cell here. So this is the data. So let me paste this data. We use the square bracket for extraction. The square bracket for extraction. Okay, and the square bracket, since this is the data, if I put one here, putting one here or anything before the comma is extracting rows, and anything I put here is extracting columns. So right now, if I put one here and I run, I've extracted the first row of the data. If I want to extract the first 5 rows of the data, I can put column to 5, and I've extracted the 5 rows of the data. I can equally use a C, which is called concatenate sign, put 1, 2, 3, 4, 5, and it will also do the same job. Why would I waste my time with this if I can just use the dollar and the quotation and then go this way? Fine. So suppose you want to so this is used for extracting rows. The first part is used for extracting rows. If I want to extract, let's say the 33rd row, I just put 33 and it extracts for me. But suppose I want to extract, let's say, the first column. Okay, the first column, I put 1 rather here. It extracts the first column. If I want to extract the first, let's say, the first 3 columns, I put 1 to 3 and it extracts the first 3 columns. Okay, so this is for extraction. So keep in mind the square bracket is for extraction, and whatever you put before the comma is for rows, and whatever you put before, if I don't put anything before the comma, it meant that I'm not putting any restrictions on the number of rows I'm extracting. But here, if I put anything here, then it means I'm restricting myself to what I put there. Okay, so that is fine. Now, so here I told you the quantitative underscore variable of any data you put here will extract only the numerical variables, and then using data with the square bracket, in a way, I'm extracting the columns of the numerical variables. And then I use this function, okay? And here you realize that I've specified the method to be equal to Pearson. So if I should run this one, okay, it is actually computing Pearson correlation. And you can see that this is giving me extra information. So first of all, it's giving the leading diagonal. Let me reduce that. Yeah. So first of all, the leading diagonal is actually the histogram plot for each of the numerical variables. For the red line is just a density plot trying to mimic normality. So even looking at the red lines, you can tell which ones appear to be normal. But keep in mind that we have also another plot to determine normality. But keep in mind, you cannot make inference, you cannot make any inference based on descriptive plot. There's a plot called KK plot or quanta plot that is also used to determine whether a data set is normally distributed or not. But keep in mind, it's descriptive. But if you should do the Shapiro-Wilk test, that is finite, that is exact. You don't have to worry about plot if the data is not normal. Unless you want to maybe show someone that your data was normally distributed, then you can also use the histogram to indicate normality, whether it's normal or not, or you can use the KK plot. To know the KK plot, if you watch the previous videos, I think the fifth YouTube video, you will see a lot of these things in there, so you don't have to worry about this. Suppose you wanted to run Kendall Tau, okay? So here I use Pearson to run Pearson correlation. I just put the Kendall here. So here I put the methods. So it can do 3 different correlation. The Pearson is the parametric correlation, okay? And the Kendall and the Spearman are non-parametric. But look at something. And keep in mind that for non-parametric, it takes into account ties. So situations where you have some data points are repeating, when you run this, you can be getting these kind of errors. It's not an error, it's giving you the results. But suppose you don't want to print this warning sign, you can remove this. You see, I put the hashtag here to just comment it. You can remove this, run this one, and then it will run without any warning. So we can actually use this in R to kind of inhibit any warning message, okay? So at the moment, let me just put it back. And we are interested in Pearson. which is what we were interested in, and you just run. Okay, so let's just look at a quick interpretation. So it's always useful if you want to do any correlation or regression, it's always useful to get this kind of plot. Okay, and you realize that values that are not significant, they look very small, and those that were significant are the ones with a star. 1 star means significant at 5%, 2 star means significant at 1%, and then 3 star means very significant at 0.1%. Fine. The whole thing is that once there is a star, at least one, it means that there's significant correlation. Now look, if I'm interested in knowing the correlation between rate and convection, it means where the two intersect. So this is rate, this is convection, they intersect here. So it meant that there was a negative correlation, but it wasn't significant because it didn't have a star. Now, if you look at this one, which one actually what is the correlation here? So look at, this is rate, where they intersect. When you come down, it's time. So it means that this minus 0.52 is actually the correlation between rate and time. And then when you come just below it, it gives you their correlation as in their scatter plots. And then these red lines, they are very useful because it tells the kind of relationship that exists, whether there exists a linear relationship or not. So for instance, this one appears to be very linear relationship. When you see something like this, it implies that the relationship is not very linear. Look at something like this. This is a clear curvilinear relationship, okay? Because you can see, so the line that these red lines actually even gives you a fair idea the type of relationship that exists between among your variables. So suppose, because I said you are using a linear model assumes that there should be a linear relationship between each of the predictors and the independent variables, isn't it? Sorry, each of the predictors is the same as independent variable. So each of the independent variables and then the dependent. Now this is the dependent variable. So if I look at the column, it will give me just relationships between the dependent and all the independent variables. So the dependent variable is going to be rate because we are predicting rate. So if you look here, it meant that convection had fairly linear relationship. Rate and execution, execution also has fairly linear relationship with rate. But if you look at time, it's not very linear, you can see. And then if you look at, let's say, income, it's also not. So this just gives you a fair idea, the type of, so it means technically, we are going to see the model we fitted. That model could have been better if I had used the GAM, the generalized additive model. You remember I told you for the generalized additive model, I'm fitting the same model, right? But I'm going to add a function called a spline function or fit splines to those. So it meant that a variable like this, income, it has a kind of nonlinear relationship with the dependent. Then I'll put a spline around it. Okay, when I put that spline function around it, it will smoothing out the non-linearity for me to get a relationship that is fairly linear. So just keep that in mind. So I wouldn't waste too much time here, and then let's proceed. Fine. So the next thing I told you was to find, so technically this is very informative. So it returns, first of all, the main diagonals are the histogram plots, okay, of each of the numeric variables, and of diagonals, the upper diagonal actually gives you the correlation between them, and the lower diagonal gives you the scatter plot, and even indicates the kind of relationship that exists, whether it's indeed fairly linear or whatever. Okay, so that is, so it gives you extra information, and that's why I love that package so much. Okay, fine. So the next one, I wanted you to find a relationship between income level and residential status, where residential status is the same thing as southern, right? And I told you with that case, you need a chi-square test instead. So to find to do a chi-square test, you just have to use this function, chi-scale.test. And then you put the first variable, which is income levels, and then southern. Okay, when you do that, it will return your so this is the chi-square, this part is the chi-square test. Okay, so let me just cut the down part just for you to see. So if you run this one, this will give you the chi-square test, and this is the p-value. And you should always understand, for any statistical test you are doing, you should always know the null hypothesis of the test. You should always know the null hypothesis and the alternative hypothesis. So you should understand that for chi-square test, the null hypothesis is that, and keep in mind, I said a chi-square is used to find correlation between two categorical variables. You cannot use chi-square to find correlation between more than two. Technically, you cannot find correlation between more than two variables at the same time, but you can use something called partial correlation to find a correlation between two variables whilst accounting for the other variables. Okay, and that is also what regression does for you. So with regression, looking at the linear relationship. So if I look at the linear relationship of, let's say, one predictor, on the dependent. Okay, if I look at that relationship, okay, it's telling me, I mean, whether there's significant correlation or not. However, don't forget that we did that by controlling other variables. So meaning that we're looking at the relationship of one variable, okay, with the dependent whilst accounting for other variables. Okay, so that is what regression does. But this one is when you want to find correlation between strictly two categorical variables. So here you just use the chi-square. Okay, yeah, I added this part. So the table, you know, the table will always return. So this is what I did earlier, where I was returning the cross tabulation, the proportion, and then I decided to multiply by 100 to find percentages, and where I rounded it to 2 decimal places. I mean, so that's basically what these things are doing here. Fine, and you don't need to worry about all these things. Like I said, we've already done that in our previous video. Fine. So now let's fit the regression, which is the last thing we are doing. So I'll run quickly. So to fit the regression, this is all you need to run in R. So LM is linear model. Okay. So all you need to do is, and this LM, I can technically also use another function. So let me use another function. Let me say GLM, and I'm going to use the length function to be Gaussian. Gaussian is the same thing as normal distribution, right? Because don't forget that OLS is assuming that the residuals are normally distributed. So let me just take this. I told you can always use either equality or the less than with this for assigning. So let's say I'm fitting a regression model. This is my dependent variable. So I'm using GLM function here, but here I'm using LM. So this LM function is strictly for OLS regression. Okay, it's strictly for OLS. But within GLM, if I change the link, okay, to, let's say, a family, sorry, if I change family to be, let's say, Gaussian, okay, let me just look at the summary of this. So the summary of the model, so know that I was fitting the model and I had to save it in an object, because I told you it's always good that anything you do, you have to save the results into something, and that thing is the object. Okay, so now let's look at this. So you find out that the results I'm getting here, just to know that our results are there, these two models I fitted are the same. Okay, now this function is used for strictly OLS. Okay, so if I run this one, now look at the coefficient. Let's say the intercept is 0.4. Okay, just to know they are the same, we can just come down and just let's type the coefficient QAF of the OLS regression. Okay, and then so it meant for this GLM function, if you wanted to do a binomial regression where your dependent variable was categorical, you just have to specify the name of the dependent variable here, bring the wiggle sign, this wiggle sign. After the wiggle sign, anything you specify here are the independent variables. So it meant the independent variables to be separate them with a plus sign, okay? And then the name of the data, and then I don't need family if I was using the LM function strictly for OLS regression, but I can still use the GLM because I told you that OLS is a type of generalized linear model where the family is Gaussian. If you put the family to be equal to, let's say, Poisson, and your dependent variable is, if your dependent variable is a count dependent variable, if it's a count data, then it will be doing Poisson regression for you, okay? And then if you put binomial, and then, so I will show you how to fit a binomial regression. Just this function, put the dependent variable if it was categorical, and then put the family to be equal to binomial, and then it does a binomial logistic regression for you. If you want to do multinomial logistic, where the dependent variable has more than 2 categories, then there's a specific function called multinomial logistic function in R, which you can always Google and take it from there. Fine. So now let's just compare that these two are giving me the same results. So I just type QAF of the Gaussian. So now let's look. So the COEF is extracting the coefficient. Now let's see. If you look at the coefficient, you can clearly see that they are the same. And so that's why I'm saying, so this implies that you can technically use the GLM function to fit the normal OLS by just setting family to be Gaussian, okay? And the Gaussian means that is the error distribution. So keep in mind, this family is actually the error distribution. So here you are saying that the error distribution should be normally distributed. If the error distribution is normally distributed, then you are mimicking the ordinary least square regression, which you can also just use this straightforward and you go fine. So we are done with that. Fine. So now after fitting your model, so let's say this was the model. the GLM, so I can use any of them because they are the same. So I'm using the OLS regression. Because of time, let me run. Then you write the par MF row 2 by 2. So this one is just to extract how many. Suppose I don't specify this and I should run this, okay? You realize that it has plotted, this is to plot residual diagnostic plot. After fitting the model, you put plot around the object name of your model. And keep in mind, after fitting a regression, you have to check whether the model's assumptions were met, because it's a parametric model, isn't it? So, and this one is having a dependent variable being numerical or continuous technically. If it was if the dependent variable was categorical, you don't really have to worry yourself about testing assumptions, because for logistic models, I mean, it's a little bit robust to assumptions. You don't have to satisfy the residual that doesn't have to be normally distributed technically, because it doesn't follow a normal or Gaussian distribution anyway. So you realize that without putting the par MF row, I'm getting different diagnostic plots, right? But it's not giving me like the way I wanted it. So putting this one is a way of plotting, let's say plotting 4 plots at the same time, where I'm considering the first one is the number of rows and this one is the number of columns. You know, I could have just made it 4. I could have just made it 4 by 1. I could have just made it 4 by 1. See what happens. So the 4 by 1, what it does is that, look, this is what it sees. So meaning that I'm plotting 4 plots, but I want 4 rows and only 1 column. I don't think that is very useful, right? It's not appealing. So I would rather use 2 by 2. And then at the end of the day, I have it this way. This particular thing gives you all the assumptions you need to know. So first of all, I added this link. If you click on this link, it will give you the interpretation, but let me just interpret it shortly because of time. So the residual versus fitted plot technically tells us whether indeed your predictors had a linear relationship with the dependent variable. So if this thing is fairly linear, there are instances where this thing could have been like a curve. The red line could have been like a curve. That's why I told you the red lines in the previous correlation matrix plots also gives us a fair idea about the type of relationship, whether linear or non-linear. If the relationship is not linear, I would want to fit splines, but rather using the generalized additive mix model instead. Because I told you the additive model, the only difference is that variables that are not having linear relationship with the dependent, after doing those exploratory analysis, you only fit splines to them to smoothen the non-linearity, isn't it? Fine. So here, if this red line is curvy, it's like a curve, then it means that like for instance, as you can see, this one is not a perfect linear relationship. However, it's still not bad. There are instances where it would have been like a curve, and that meant that clearly all your variables had a non-linear relationship. But this one, when it happens this way, it means some are having linear relationship, but not all. So it will only inform in our coefficient of determination. Coefficient of determination is one of the ways to check the power or the performance of your model. So it tells you the proportion of variance explained in your dependent variable. Okay. Now the proportion of variance explained, the magnitude of the proportion explained also gives an indication of how good your model is. So if it's explaining, let's say 80% is doing well, at least 60 is not bad. But when it's like, let's say 10% or 0.1, 0.2, then you should be worried. Then it means you have to do some transformation, maybe do the transformation to the dependent variable, or take maybe, especially when your dependent variable has large variance. Suppose the variability in the dependent variable is large, then it meant you might want to take log transform, or use a certain transformation called the Box and Cox transformation. It helps you to determine the best transformation you need to do to your data, whether you have to take log or you take square root or whatever. Each of the transformation is just to minimize the variance in your dependent variable. Fine. But there are instances it's not the dependent variable that is having the problem. There are instances it's probably because the predictors are not having a linear relationship. So I would fit splines to such predictors that we're not having a linear relationship. Fine. So let me just run. So this one gives a fair idea about the linearity between the dependent variables and the independent. Okay. So this implies that it's not bad enough. Now let's come here. So this one is what I call the normal KQ plot. So this one technically, if you were seeing some of the plot deviating too much from this line of best fit, you see this dot lines. So this line of best fit, if most of the points were deviating too much from it, then you can say that then it appears that the residual, because we said the regression residual should be normally distributed, isn't it? Or it should be normally distributed. But it appears that in this case, there are little bit deviations. However, most of the points are still on the line of best fit. So this model is not bad. It's not too bad. There are instances where the point will deviate technically, and then you know that the residual. So once the residual is not normally distributed, then it means that you need to do some transformation, whether to dependent or independent, do some transformation, whether fitting splines or whether taking log transforms or doing something. And if after doing all the transformation, you're not getting a good fit, it means that the OLS regression is not good enough for you. So in that case, I would want to fit a generalized least square regression, which doesn't worry about normality of the residuals. Okay, fine. And then, so that's the first two interpretation. Now the scale location. So this technically is for the homoscedastic assumption. Yesterday, someone asked me about that. So how would you know? I mean, your variants are fairly the same. So you realize that this particular line. So if it is also fairly straight, okay, fairly straight doesn't mean it to be strictly straight. Okay, even this one, there's a linear relationship, just that it's not perfect. I mean, if it was perfect, that's when we say we have a perfect relationship of the predictors on the independent. Of the predictors on the dependent, but in reality, you will not get a perfect fit. Okay, sometimes if you even get a perfect fit, it might be due to something we call overfitting, or it could be due to the fact that probably there's multicollinearity that is resulting in such overfitting or something. So fine. So nothing is perfect here. So here too, if this red line is very curvy, if it wasn't very straight in some sense, then that would tell us, so if it is curvy, for instance, then it means that the residuals are heteroscedastic, okay? And then we expect these points not to deviate too much from this line. And you can clearly see that these points are not deviating too much, and they are equidistant from each other. They are not very dispersed from each other. So this also tells us a little bit that for our case, we wouldn't want to say the homoscedastic assumption was fully met, but it appears to be met and is doing fairly okay than if this red line had been like a curve. Okay, fine. And this is the last thing. This part is very useful. Okay, so this is the residual versus leverage plot. It helps us to determine which of the observations, okay, are technically influential. If I say influential observations are observations that are either causing the model to perform badly, or when we should take them out, we could get a better result. Okay, so keep in mind that for influential variables, classically, you could have just said they are like outliers, isn't it? So, but we wouldn't want to use the word outliers in our case. We just want to use the word influential. So how would you know they are influential variables or variables that we need to take out? Okay. So what we do is that there are instances where there are instances where you will not see this red line. You see this red line, and this red line. We call it the Cook's distance. When you fit a model and you don't see this Cook distance, it meant that in your data there's nothing like influential variables. Okay, so it meant that it's okay and work with that. But there are instances when you have this red line and there's any value outside this red line, like this one. This one is the 28th observation. Don't forget that this is not 0. This is just the data point, okay? So this one is saying that the 28th observation is an influential variable. What it means is that if I should take the 28th observation from this data, I'll get a better fit. Let's find out whether it's true. So keep in mind that this one helps us to determine whether, so anytime you don't see the Cook's distance, okay, after doing your diagnostic plot, okay, we call it residual diagnostic plot, and you don't see this red line, then it meant that everything is okay. But the very moment you see these red lines and there's anything outside these red lines, it means if you extract that row of that data or that observation or that individual from the study or take it away from your data, you will get a better fit. Okay, now let's go. So it meant that after fitting a model, you should always check the residual diagnostic to see whether indeed you need to do something more to the data you fitted. Okay, so now I've identified an influential variable. The 28th observation is not helping us. Let's go and see. But this model we fitted is not too bad. If you look at the coefficient of determination, it's technically 0.74. Okay, 5. 0.745. This implies that approximately like 75% of the variance in the dependent variable is accounted for by the model. And I told you that the higher the value, the better the model. But it is not always so. That is if you are comparing between two different models. Keep in mind that if I have a regression model of only 2 predictors, and I have a regression model of those 2 predictors plus an additional one, the coefficient of determination with the third variable, the model with the third will automatically be higher than the previous one, even if the third variable I added was significant or not. So that's why increasing values of coefficient of determination does not necessarily imply a good fit, okay? But the very moment you fit a single model, the coefficient of determination is what you use as a measure to conclude on which one is doing well. But if you are comparing between two models and they are having the same number of independent variables, then you can still stick to the coefficient of determination. But if you are comparing between two models where one is having more independent variables than the other one, don't use coefficient of determination for comparison, because the model with more variables will automatically do better, which is not supposed to be so technically, even if they depend that extra variables were significant or not. So keep that in mind. In that instant, you might want to use something called AICs, okay, which we'll find out there. AIC is just a key information criterion that you can actually use to find which model is doing. So it's used for model selection among models of the same kind. If I'm comparing, let's say, regression model with, let's say, machine learning algorithm, the same thing I did. I could have just done it using a machine learning algorithm, like, let's say, classification tree, and then I would want to compare which one is doing better. So in that case, I would have computed something you call the mean absolute percentage error, mean square error, and mean absolute deviation. Those are what we use. Those are what we call predictive accuracies, or those are the prediction errors that you should compute when you're comparing models of different kind. But whenever you are comparing models of the same kind, we use either the AIC or the BIC. AIC is archaic information criterion. BIC is Bayesian information criterion. But it appears that the AIC is better than the BIC because it's less susceptible to outliers. So it's always good to go for AIC if you are comparing between models of the same kind. But if you are comparing regression models and there are two OLS regression models, and they are both having the same number of independent variables, okay, the same number of independent variables, 3 or 3, 4 or 4, then you can still stick to the R square, okay? But the R square, there's something called the adjusted R square. It's always important to report on the adjusted R square in your research instead of reporting on the unadjusted R square. The reason is because the unadjusted R square is not taking into account the significance of every variable, but the adjusted R square is trying to penalize those that were not significant, or is trying to incorporate the variables that are, so in essence, it's incorporating the significance of each variable also in computing the R square. So always the adjusted R square is good. And that's why I said you should always report on adjusted R square, because it takes into account the significance of each of the predictors as well. Okay, fine. So let's go on. All right, so now what I did, what did I do? So this is just the residual plot we did earlier. So the next thing was, I said I was going to take the influential variable, because we saw that from the Cook's, the residual leverage plot, okay, there was an observation outside the Cook's distance, okay, the Cook's distance boundaries. So we want to take the 28th observation out. Now let's see. Remember, the coefficient of determination was, remember, that is the unadjusted is 0.74, okay, 0.745. Okay, let's come down. So now with this data, when you use negative, you know that if I had just used 28, it was going to extract the 28th variable. But if I put minus 28, it means that it's taking away the 28th, did I say variable, observation? If I use 28 here, it will extract the 28th row, okay? The 28th row. And the 28th row for a cross-sectional data is the same thing as the 28th individual observation. If I put minus here, it's rather taking that individual out. Instead of extracting that, it's taking it out. So here I've run that to take out the 28th observation. That's why I'm calling it. So I'm saving it in a new data set. I mean, a new object name called data without observation 28. Now let me run this one. Before I took it out, I had 2 stars. It meant that only time and then the residential status technically influenced the rate, because they are having star, and the significance is at 5%. Okay, the rest didn't have any significant effect in predicting the rate of murder. Okay, but now after taking the influential variable out, now see, now technically if we are having 3 variables that were significant, meaning that influential variable caused the non-Caucasian variable status, it caused it to be insignificant here. It caused it to be insignificant. Okay, it caused it to be insignificant because the p-value was not significant at 5%. It was rather significant at 10% alpha level, but no one works with 10% alpha level. The 10% alpha level implies that you are assuming that you are going to consume or allow 10% degree of error in your results. And no one does that. At least you work with what? At most you work with 5% alpha level. That's literally being chosen like a standard. Unless you are testing effectiveness of drugs, then you want to choose your significance level or your alpha level to be 1%, because in that case it means you are interested in concluding with 99% level of confidence. Okay, fine. So now let's look at so we've fitted. So now let me come down here. So now we've taken the 28th observation out, or the influential observation. Now we fitted and we saw that now it has made another variable even significant. And now let's look at the residual plot. Let's come back. So you find out that this time around there's no influential variable outside the leverage thresholds or bounds, okay, or curves. There's no influential variable there. Now let's compare the R square. Now if I compare the R square with the influential variable present, that is the first one, the coefficient of determination was 0.4745. But after taking it out, the coefficient of determination is now 0.792. You see, so that tells you that these influential variables can really affect the degree of accuracy of your model, okay? So it's always good to always do the diagnostic plot checks and then do all these things, like I said. And suppose you wanted to do a binomial logistic. So this, I'm technically done. Suppose you wanted to do a binomial logistic regression, okay? I told you for binomial logistic regression, your dependent variable has to be what? Categorical. So suppose you were interested in predicting the status. So the residential status, maybe you wanted to determine whether, depending on your conviction, depending on your rate, the rate of death, depending on your income level, your rate of, MEDA rate, and depending on your income level, whatever, where are you more likely to stay? Are you more likely to stay in the southern part or not? So in that case, in that case, my dependent variable is going to be the southern, okay, and all the other things is going to be the independent variable. You realize I didn't bring income level because of the fact that I was using income. Okay, suppose I want to use income level instead in this case. Fine. Now here, keep in mind that anytime you have categorical variables, it will always keep one variable as reference. So you realize that for the numerical variables, you have the name and then whether it's significant or not. Fine. The significance of the intercept is not really of interest to us. But here, Southern had two categories. It had yes or no. But I realized that it has extracted only yes, and then we didn't see anything about no. The reason is because it keeps no reference. Why is that so? It implies that the regression coefficient for categorical variables are always computed by keeping one of the levels reference. So if you have 3 levels, it will automatically keep the first one reference. You can always change it, which one you want to keep reference, by using a function called relevel to choose which one you want to but by default it chooses the first one reference, and when it chooses the first one reference, it helps you based on this one. If this is positive, it tells you that, oh, indeed individuals who are staying in the south indeed has what they technically have a higher rate or a higher chance of what of causing a murder, okay, because you can see that there's a positive coefficient. So these coefficients are what you call the effect sizes, okay. So this one implies that, and if I want to know how many times that individuals in the south are more likely to cause murder, all I need to do is I just have to extract the coefficient. Let me come down here. I just have to type coefficient, extract the coefficient of this, and I'm interested in the coefficient of the last variable, right? So I will just use the last variable is so we have 1 2 3 4 5 sorry 1 2 3 4 5 6 7 8. So if I should put 8 here, okay, it will extract the coefficient for just yes. Now if I type exponent, okay, around this one, okay, if it was a logistic regression, exponent of the coefficient of determination compute something called the hazard ratio, okay. So if you do the logistic and you type exponent of the log odds coefficient, you get a hazard ratio. So suppose this one was a logistic regression model, okay, it would have told me that individuals from the south are approximately 41 times more likely to cause murder. Okay, so basically that's what it's doing. But for the regression sense, you wouldn't use the hazard. I mean, you wouldn't compute hazard ratios from, because you cannot do that. You rather use this one. This one is saying that individuals who are in the south, okay, are approximately also 3.7 units more likely to cause, or individuals in the South have their murder rate increasing by 3.7 times as compared to those with, who are not in the South. So this is technically how you would have interpreted for the OLS case. So for the logistics, suppose I was interested in predicting depending on this information, where are you likely to be staying? Are you likely to be in the southern part or not? Then I would just have to put family equals binomial. You remember, I'm still using GLM. And you remember, if I set the family to be Gaussian, it's also doing the same OLS that I did with the LM function, right? So now if I should run this one, income level, did I have, let me check. So if I should, okay, because I'm using, I think I'm using the new data. So let me just copy. No, where's the new data? Okay, so I'm copying this one instead, this one, and then I'm pasting. I'm choosing it here. Income level. Let me check. So names of that. Okay, so you realize that, oh, okay, so here, that's one thing you should be careful. So always check the names to be sure of how you labeled it. So I labeled it as income levels, not income levels. So I have to add S to it. Okay, fine. So when you do it this way, this one is not a good model anyway. I was just trying to show you how you do a binomial regression, because all the p-values are not significant in our case. In this case, fine. Trying to distinguish factors, trying to determine whether you are more likely to stay in the South or not. It wasn't very useful. But this is just to tell you how you would have done a binomial logistic regression. Suppose you had a binomial outcome or a binary outcome and you wanted to make prediction. Okay, if this variable was account data, if the dependent variable was rather number of accidents or number of murder cases, I would have changed the family to be Poisson, and I would have used a Poisson regression. In that case, you've done Poisson regression. So without wasting time, I will end here. And then don't forget that the whole, everything we've done so far will be uploaded on YouTube. And then you can also sign up to my class and benefit a lot from everything we've done. This is just a teaser. You will learn a lot from the videos. By the time you go through everything, I'm sure you will become almost a great statistician, and then you should be able to do any analysis you want. And then one thing is that we cannot use just one day to learn everything. So this is just an exposure. And then you can always, one thing about R is that if you want to now do anything, suppose you wanted to fit a generalized linear mixed model, okay, and you want to know how to fit a generalized, you don't know how to fit a generalized linear mixed model, but you know when we use a generalized linear mixed model. I explained it yesterday. In that case, you just go to Google and type how to fit a generalized, you just type how to fit a generalized linear mixed model. And once you type that, you will be able to get some specific package you are supposed to download. So anytime you go to a website and you see they've written library of something, it meant that that thing is a package you need to install before you can use some of the functions down there. So what you need to do is that to install, you use install.packages around that package before you can actually install. And after installing, you don't have to install again. You just have to use a library to load it. So I'll just end here, and then so if you want to join my class, so this is just a teaser. If you want to join my class and learn, you can send me your email, and then you can also send it to Gilbert, and then or any of the NUGS-Shanghai executives, and I should be able to get them. And then the class is free. And once you sign up, you're able to download. So all the script I use, you see how powerful R is. You can create your own functions to do anything you want to do. So all the script that I use, you can technically download them on Piazza if you are part of the class. So and it's a free thing. I technically did it for everyone. So why don't you just join, benefit from it? And I'll be going on a break after today's class. For that class, I'm going on a break. So meaning that we are in for the whole of December, we are not going to do anything on the class. But these two, yesterday's session and today's session will be uploaded on YouTube, right? So it meant that those will be the last two videos I'm going to upload on YouTube. Fine. But afterwards, I need a break because I've been stressing myself a lot. It's like, because I do a lot of things whilst I'm doing my PhD teaching, and then I'm doing project and doing other things. So at the end of the day, I'm very stressed and I need some time out. So the whole of December, I'm not going to do anything on on the class. So use that as an opportunity, especially for those who have never joined my class or those who are now going to start from scratch. Use that break period as an opportunity to learn. Start from the first YouTube video, get access to all the data, the script, everything, and be practicing, okay? And there were a lot of assignment tasks, practice them, learn them, and then by the time you realize, it's like you are getting good. So make sure before the end of December or by the end of December, you should have gone through all the YouTube videos, you should have been able to do all the practice tasks, and then you should have been able to get access to the course and everything. And then don't forget to watch these last YouTube videos, which is yesterday's course and today's talk as well. And then, yeah, thank you very much. And then it's great having you here. Thank you very much.
All right, thank you. Thank you.
Is there any question? Anyone has any question? I'm happy to answer them. If not, then the executive can take over from there. Any question? Any specific question? It could be something outside what I did. It could be anything. I'm ready for anything.
Doc, I think someone was asking if you could, they could get access to the data you used today.
Exactly. That's why I'm saying that if you enroll to the course, okay, which is so free, just send me your email. I will automatically add you to the course, and then I'll send an email, a link for you to just follow and sign up to the course. Once you sign up to the Piazza, you'll be able to have access to everything, and you can download all the YouTube videos. Everything will be there. I'll even send the YouTube videos, everything to your email, okay, and then you have access to all the script, not just for what I use today, access to everything I've done for the entire course, announcement, everything will be there. So just sign up, and then make sure you don't forget to subscribe. The subscription help is just a form to motivate me a little bit. You don't even pay anything for subscribing, isn't it? But I need quite a number of subscription before I can get any incentives from it. But technically, that wasn't my main motivation. My main motivation is to help people, and then I don't get anything from it technically. So it's just to help. It's just what I do. I mean, it's my philanthropic work. It's what I do to help people. I like to help. Yeah, so that's what I decided. Instead of people calling me, oh, I want help for this, everyone is calling for that, I'll break down. So I decided to, why don't I combine everyone like a class? Then in that case, if you want any help, then go back to the YouTube video, you'll be fine. So that's basically what motivated my YouTube class. I mean, and also, like I said, to promote mathematical programming among students from Africa. We need programmers, and then our country needs us to be good programmers to be able to help contribute to development and so on. Just imagine this one, we predicted rate of murder in a country. So meaning that statistics is so realistic that it can technically, you can use it for any research you are doing, and then you can get more interesting findings from it. Thank you. Any question?
Great. I think Chris from the Hujo organizer, please, you can unmute yourself and ask your question.
Okay. Yeah, thank you very much for your presentation. I think from now onwards, I'll be one of your students, and I'll follow whatever you are doing on YouTube. I want to ask, in the case where, I think I didn't join the class from the beginning, okay, but I don't know where the data was imported from. But I want to ask that in the case where the data will be taken from, let's say, a sensor or a digital twin, or let's say any virtual source, okay, how is R able to get that data?
Great. So one beauty about R is that you can technically import data directly from a website. You can actually import data from a cloud. You can actually import JSON data. You can import data from Twitter. You can import that. You just need a package. So if you want to import data from, let's say, Twitter, you just type how to import data in in Twitter into R. Okay, just Google, and then you get blogs. People have done blogs in explaining these things. Okay, so technically you can do that. And the package, but the best way to always import the data is if you can save it as a CSV. So if you have created a data in Excel, just save it as a CSV. After saving it as a CSV, put it in your repository. It's always good to create a repository, is just creating a folder on your desktop or anywhere, and then put your data in there. Go and copy the working directory. You saw how I did it. If you watch, even with this, at the beginning, I showed them how you set your working directory and then import your data directly from the working directory. And I even show them how you save your graphs directly into your working directory. Okay. And if you go through the YouTube videos, in terms of the ones I've already done, I mean, everything will be fine for you. Yeah.
All right. Thank you very much.
Thank you very much for answering, Doc. Doc, someone is asking, how do you send your email? Probably, maybe you can type
Okay,
your
so for my
there.
email, so technically, to everyone, is I'm putting it on the chat. So it's chumesi@cardiff.ac. So it implies that I don't help anyone with their project. So that's one thing, because I don't want to. I'm stressed. It's like I get a lot of calls every single day, so I'm always stressed. So technically, what I can always do is that I've done. That's why I'm doing everything for the YouTube class or my class. Is technically just to be able to, if anyone needs help, just go to the source. I've explained everything there, and then make sure you use R, because one thing I want to make clear, there were some people were applying to schools, especially outside Ghana. And I mean, outside any country you find yourself, especially when you want to come to Europe. And most of the countries in Europe, UK, some schools were asking others to show evidence of their statistical, background or statistical analysis they've done, okay? And whether they've attended any form of class or whatever, they should specify. And then they should specify their knowledge in using a statistical software. So imagine if you didn't know anything about statistical analysis and you wanted to apply for this course, and then that course was going to give you a scholarship. So are you going to say that because you are not knowledgeable with statistics, you are going to sit down and for the scholarship to just go away? For instance, mine is a vice chancellor scholarship, and imagine you needed to be able to be good with these things, which is so before you can. So in that case, are you going to just let it go away? No. So that is why I want you to understand that you might not be in need of statistics at the moment, but it is a skill. It is a skill that with that, you don't even have to think about employment, because you can actually be working in a research firm. You can actually be, doing analysis for students, for people, and be charging. I mean, it's just a self-employment. It's a skill. I see statistics and data analysis technically as a skill, not a course to me, because it has made a lot in my life. Okay, so that's it.
Thank you very much, Doc. Please, is there any question, any additional question? Because, like he said, he's going on a break, so it would be good if you ask your questions here.
Yeah, but since I'm going on a break, once you send me the emails, I'll send you the link for you to join Piazza, and then I'll send you all the YouTube videos. Everything, but technically, all the YouTube videos would be on Piazza, but I'll still add all the YouTube links also in there, and I'll be waiting on the executives to get me the links for, the recording specifically on my talk for yesterday and today, so that I can upload it on YouTube as well. Yeah, so I'm on a break, but if someone has any specific questions, maybe, and you want to send me via email, I don't mind. But questions like, can you do this for me? That is what I can't do because I'm very stressed. But if it's something you just want to call me to get my idea about something we're trying to do, okay, that you were struggling, then for giving you ideas and hints, I'm happy to do. But to actually do it for you, I don't think it's a good habit. And so I technically want to stop doing that. I used to do that, but I don't think it's good enough for me to be doing that. So I can help give advice even within the break, but as in doing something for someone, I might break down if I was doing that for every single person who calls. So thank you.
Great. Okay, so if there's no any question, then we want to use this opportunity this time to thank Doc. To thank Doc so much for the amazing studies, for the amazing knowledge that you've given to us for within these 2 days. We want to say that we are so much grateful. We thank God for your life, that even in this hardship, you are still speaking to us, teaching us. Teaching us is that, sorry. Okay. So we thank you so much for this time. We thank you so much for your time. You didn't even ask us for anything. I mean, we really appreciate that. And nevertheless, we want to use this time to appreciate our NEC executives, Honorable Collins, Honorable Francisca, our organizer, and all the other chapter executives and members who joined this program. We are privileged and humbled to have you guys to enjoy and be part of this program. We want to say that we are very much grateful for you being with us. I'm sure we've learned a lot about R. I've seen the R and the logo and everything, but I didn't know anything about it. But at least for what you've taught us, I think I know a bit, which is encouraging me to go and learn more and go to YouTube to learn more about that. So I will encourage each and everyone that if possible, like you said, you might not need it now, but you can learn that for the future. So we are encouraged to do that. And also lastly, we want to thank all the amazing people, those who are not from Ghana, our brothers from different countries, brothers from different schools. We are much grateful and we are very happy to have you on board. And God bless you for your time. God bless you for being with us. So without wasting much time, we will call on Mr. Divine Carson Bill to pray for us, to give us the closing prayer so that we can end this meeting with God. If Divine is not here, then shall we call upon our own Honorable Suleimana to give us the closing prayer for today?
Okay, let's pray. We thank Almighty Allah for taking us through this informative and educative program, and we pray that He blesses all of us and make sure that everything that we have learned today will impact our lives in positive ways. And we also pray that Almighty Allah protects our brother Clement Chumesi so that he will impart more into the lives of other Ghanaians alike, and to protect every member of NUGS-Shanghai and NUGS-CHINA, and strengthen our union, and also to help us organize similar programs that will impact the lives of our members. So Alhamdulillah Rabbil Alameen Ar-Rahman Ar-Rahim Maliki Yawmiddin Iyyaka na'budu wa iyyaka nasta'in ihdinas siratal mustaqim siratal ladzina an'amta 'alaihim ghayril maghdubi 'alaihim waladdallin. Amin. Amin.
11:24. Hello, can you hear me? Hello, am I being heard? Anyways, it's just an announcement coming from Nanjing chapter. Yeah. So this is Clement, the organizer from Nanjing. So we'll be having our program tomorrow, and as you saw this program being a blast, tomorrow's program is going to be a blast. It's on financial freedom, and we urge all of you to be on. I think when you log on, it's going to be the best for all of us. So I believe let's all log on and have a great time as we keep our learning progress on. I wish to see all of you there tomorrow. It's 8 o'clock live in Khaled. We're going to have and hear from great personnel to which would educate us on how to keep ourselves free from financial difficulties. I believe when we learn from these in the near future, we can use it to help ourselves get rich and probably get rich forever. Thank you guys all.